This is our summer video number 4 in our AP Calculus series. We're going to start this video by going over the worksheet that we looked at in the previous video. And basically, we always start trying to evaluate limits by doing a direct substitution. If that doesn't work, then we have to get a little tricky, and we're going to talk about that a little more in this video. But for now, let's just do our direct substitution. So we're going to do 3 times 4 minus 7, which gives me 5. Okay, pretty straightforward, right? Here again, we're going to do our direct substitution. So that's going to be 2 times 1 minus 3 times 1 plus 4 times 1 plus 5. And that's going to give us 8. These are actually so easy that you actually kind of start to think that you must be doing it wrong, but that's exactly what we're doing. We're just doing a direct substitution. So here we're going to get 3 times 2 over the square root of 4 times 2 plus 1 and then minus 1. So we've got 6 over the square root of 9 minus 1. So that's 6 over 3 minus 1, which gives us 6 over 2, which is 3. Okay. Now, number 4 is a little bit different because there is no x in that equation. And that's actually one of the properties of limits, that if you take the limit of a constant, it actually just equals the constant. The property actually looks like this. The limit as x approaches any number of a constant is equal to the constant. Okay, so this is just simply going to equal 6. And if you were to look at this graphically, if I were to graph the line y equals 6, right, here's that line right here, right? And if we look at what's happening as x is approaching 2, right, as x approaches 2, well, what's the y approaching? It's approaching 6, right? It doesn't move. It's just approaching 6 no matter what x value. Okay. Okay, now this one gets a little tricky. So we have a piecewise function. The first part of it is looking for the limit as x approaches 5 from the right. That's what that little plus sign means, from the right. So that means as x approaches 5 from x values that are greater than 5. So that means we're looking at this part of the piecewise function because this is where x is greater than 5. So we're using this function. That means we're going to still do our direct substitution, and we get 15. Now, as we approach 5 from the left, we're going to use this part. Okay? And we're talking about close to 5. So I know that, right, here's x equals 5, right? I know that this is also to the left of 5, but we're looking at x values that are approaching 5. So we're looking here, okay? And that would fall in this range between -5 and 5. So we're going to use that part of the piecewise function. So we're going to use the 25 minus x squared, right? And that's going to give me the square root of 25 minus 5 squared, which is the square root of 0, which gives me 0. Okay. Okay, now if we look at the next one, it's looking for the limit as x approaches -5 from the left. So I want to go values to the left of -5. Well, that's this one right here, this part of the piecewise function. And in that case, it's just going to equal 0. And then letter D, we've got x approaching -5 from the right. So again, although we have two functions that are approaching from the right, This one is the one we're going to use because it's closer to the negative 5. So we're looking again at the square root of 25 minus x squared. And that's going to be the square root of 25 minus negative 5 squared, which will also equal 0. Okay. Okay, letter E. Now we're getting tricky. And this is really an important concept here. We've got the limit as x approaches 5. Well, that has to be, in order to do that, I have to look at the limit as x approaches 5 from the left, and I have to look at the limit as x approaches 5 from the right. Okay, now graphically speaking, I'm just going to kind of draw it up here in this space here. Right, let's just say that this is x equals 5, right? So we looked at this before. Let's say that we had something going like this, right? Approaching from the left is different than approaching from the right. And in this case, we determined that the limit does not exist. Now, if I have something like this, where approaching from the right is actually the same as approaching from the left, then the limit would exist. Okay, so we have to look at both sides. Well, we already calculated the limit as x approaches 5 from the left. That was equal to 0. And the limit as x approaches 5 from the right, that's equal to 15. They are not the same. They're not equal. Therefore, the limit as x approaches 5 does not exist. Okay. Okay, now the next one, we're going to do the same thing. We're going to look at the limit as x approaches negative 5 from the left, right? So the limit as x approaches negative 5 from the left. And that equals 0. We did that in part C. And then the limit as x approaches negative 5 from the right. We did that in part D. That equals 0. They're both the same. Therefore, the limit does exist and it equals 0. Okay. All right, let's move on to the next page. Okay. So here, number 1, we've got the limit as x approaches 1 of 4 times f of x. Well, that's the same thing as 4 times the limit as x approaches 1 of f of x, which equals 4 times 8, which is 32. Okay. Okay, number 2, we've got the limit as x approaches 1 of f of x, right? And we're going to divide that by the limit as x approaches 1 of h of x. And that equals 8 over 2, which is 4. Okay. All right, next one, right? Separating this, we've got the limit as x approaches 1 of f of x times the limit as x approaches 1 of g of x divided by the limit as x approaches, oops, sorry, let's try that again. Divided by the limit as x approaches 1 of h of x, which equals 8 times 3 divided by 2, and that gives me 12. Okay, the last one. We're looking at the limit as x approaches 1 f of x, And we're dividing that by limit as x approaches 1 g of x minus the limit as x approaches 1 h of x, which equals 8 divided by 3 plus 2. So we get 8 over 5. And we're done. So let's look at some other techniques. A lot of times when we are trying to take the limit of a function, we run into some problems. So for instance, let's say that I wanted to take the limit as x approaches 1 of x squared minus 1 over x minus 1. Okay, now here, if we try to do a direct substitution, I'm going to get 1 squared minus 1 over 1 minus 1. So I'm going to get a 0 in the denominator, which means it's undefined. In this case, I'm also going to get a 0 in the numerator. So we can see that we have a problem. So one of the things that we want to do when this happens, or actually any time, not just when this happens, one of the things we want to try to do before we do a direct substitution is to simplify the expression. So what I mean by that is we're going to rewrite this as a limit as x approaches 1, and we're going to factor this. That'll factor as x plus 1 times x minus 1. And we're going to divide that by x minus 1. Now when we do that, we can see that the x minus 1's will cancel, and we end up having the limit as x approaches 1 of x plus 1, which will equal 1 plus 1, and that gives me 2. Okay, let's just look at this function on the calculator and see what's going on. Okay, oops, get some of this other junk out of here. Okay, so let's look at x squared minus 1, and we're dividing that by x minus 1. Okay, we're just going to graph that into standard window. Okay, so when we look at this on the calculator, right, we don't see any problem at x equals 1, right? So for instance, if I trace, okay, right now you can see I'm at the point 0, 1, right? And if I move along, watch my coordinates down the bottom, okay? 0.75, x equals 0.9090, right? Everything looks fine, doesn't it? It's just moving right along with no problem. What happens if I calculate, so I'm going to go second, calculate the value when x equals 1? It leaves the y blank. That means there is no value when x equals 1. See, if I do a calculate value at x equals 0.999, I get an answer. If I do a calculate value at 1.001, I get an answer. But if I do a calculate value at x equals 1, I get no answer. That's because this function is undefined at x equals 1. However, if you look at the limit, look what's happening here, right? As I'm getting closer to 1, let me see if I can figure out how to get a pen on here. I don't know if I can. I thought I could, but maybe I can't. Can I get a pen? Uh-oh. Uh-oh. What do I do? Never mind. It's not going to work for me. Okay, let's just go back. That's okay. Right? If we look at this, what's happening as x is getting closer to 1, right? Y is getting closer and closer to 2. It never actually equals 2. There's actually an open circle there, right? If I look at the table, right? Look what happens. There you go, right? I have an error at 1. If I change that table set to be, let's see, we'll start it at 1, and we'll change this to like 0.01, right? Okay, look what happens. It gets really close, but it never actually equals 1. And the problem is with the calculator is that it's graphing these lines. The way it graphs the lines is it plots points. It just plots points. And it connects every point. So it plots the point 1.99 or 0.99 comma 1.99 and then 1.01 comma 2.01, and then it connects those 2 points. So when you look at the graph, it looks like it goes through that point, but it doesn't. Okay, so we have to be really careful with that on the calculator. Okay, let's look at another example. Let's look at the limit as x approaches -3 of x squared plus x minus 6 over x plus 3. Okay, so here again, we have an issue because if we do a direct substitution, we're going to get a 0 in the denominator. So that's going to give us a point where it's undefined. So if you look at it though, I can rewrite this. I can simplify it, right? So the numerator is going to factor x plus 3, x minus 2 over x plus 3. That's how my numerator is going to factor. And by doing that, my x plus 3's will cancel, and I'm left with the limit as x approaches -3 of x minus 2. So if I substitute the -3 in there, I get -3 minus 2 equals -5. Okay, pretty simple, right? All right, so let's see here. Let's look at what happens with some radicals, okay? So here's another example. So what the technique we just used up there was a factoring technique, okay? So now we're going to look at some rationalizing techniques, okay? So let's look at the limit as x approaches 0, and we're going to do the square root of x plus 1 minus 1 over x. So right away, I know I have a problem because the direct substitution is going to fail. I'm going to end up with a 0 over 0, right? Because on top, I'm going to get 1 minus 1, and on the bottom, I'm going to get 0, and that's going to be 0 over 0. So I immediately know I have a problem. So what we're going to do is we're going to rationalize. In this case, we're going to rationalize the numerator. Okay? If we have to, we can rationalize the denominator also. And we do this by multiplying by one of my favorite words. Remember this? Multiply by the conjugate. Yeah. Pull out the conjugate. Got to multiply by the conjugate. Okay, so what is the conjugate? We're going to take the square root of x plus 1 plus 1. Remember, we changed that sign right there. That's the conjugate. And we're going to do that on the top and the bottom. Okay. Okay, so now we've got some algebra to do here. Let's see, what's that going to give us? That gives us the limit as x approaches 0. Okay, now we've got, I'm going to write it out over here for you. The square root of x plus 1 minus 1 times the square root of x plus 1 plus 1. Okay, we're going to FOIL this. So the square root of x plus 1 times the square root of x plus 1 gives us x plus 1. The square roots disappear. Right? And then we're going to do plus the square root of x plus 1. And then it's going to be minus the square root of x plus 1. And then we've got, oops, and then we've got negative 1 times 1. So that'll be minus 1 over x times the square root of x plus 1 plus 1. Okay, so what do we have up top? Okay, these square roots cancel, and I'm left with x plus 1 minus 1 over x times the square root of x plus 1 plus 1. And notice I did not multiply that one on the bottom out. I just left that alone. Okay, I'll multiply it out later if I determine that I need to. Okay, this is going to give me the limit as x approaches 0. Okay, here my 1's will cancel. So I have x over x times the square root of x plus 1 plus 1. Well, that looks like it's still a problem because I'm going to have a 0 in the denominator. But it's not, because these x's are now going to cancel. And that leaves me with the limit as x approaches 0 of 1 over the square root of x plus 1 minus 1. Wait a minute, there's a problem. Why is there a problem? Oh, I'm sorry. This is plus 1. There you go. Phew, scared me. Okay, so doing a direct substitution now, I get 1 over the square root of 0 plus 1, so that's 1 plus 1, which gives me 1 over 2. And there's our answer. Not bad, eh? The limit as x approaches 4 of the square root of x plus 5 minus 3 over x minus 4. So when we look at this, we can see once again, we're going to get that square root of 9, which is 3. 3 minus 3 is 0 over 0. So here we have a problem again. So we're going to go ahead and multiply by the conjugate. So we're going to multiply by the square root of x plus 5 plus 3 over the square root of x plus 5 plus 3. Okay, that's going to give us the limit as x approaches 4 Okay, and we're going to FOIL again, right? So there we get just x plus 5, okay? And then when we multiply the outsides, we get 3 square root of x plus 5, and when we multiply the inside, we get negative 3. These two parts are always going to cancel out if you multiply by the conjugate. Okay, those middle pieces will always cancel when you multiply by the conjugate. Okay, and then the last part, we do the negative 3 times the positive 3, so we get minus 9. Okay, and then down here, I'm going to leave it as x minus 4 times the square root of x plus 5 plus 3. And we'll wait and see what we have to do with that. Okay, so on top, I have the limit as x approaches 4, and we have x plus 5 minus 9 over x minus 4 times the square root of x plus 5 plus 3. This is equal to, right? This is x minus 4. So the x minus 4s are going to cancel. So I'm left with the limit as x approaches 4 of 1 over the square root of x plus 5 plus 3, which equals 1 over the square root of 9 plus 3, and that gives me 1 over 3 plus 3, which equals 1 over 6. And we're finished. Okay, so we multiplied by the conjugate. Okay, so there's a link for you to open up the worksheet. Make sure that you either print it out and take a picture or complete it in your Notability. And that completes our video number 4.